My name is Gabi. I work for ING Tech. Before I start, I want to share something with you. Yesterday evening, while I was going through the presentation, my daughter was crying. By the way, she's 2 months old. And my wife was trying to comfort her. And because I had to do some work, I started talking about programming and about functions and so on. And after 2 minutes, it was a complete silence. She fell asleep. So I hope this will not happen to you. If it does, it means that what I'm going to say is, I don't know, too easy? Oh. OK. So as I said, I work for ING Tech. I am a software engineer, even though that's not entirely true, because I am usually involved in all the stages of a product's lifecycle, from business requirements to software architecture, development, testing, deployment, and so on. I usually use any tool I have to get the job done, but I have 2 favorites, Kotlin and Scala. And I'm also the Kotlin user group organizer, where we are trying to have regular meetups about Kotlin technologies and about stuff related to Kotlin. So what is Kotlin? Who is working with Kotlin? OK, 1 person. Do you have Kotlin in production? Oh, cool. And do you do functional programming in Kotlin? Not really. OK, so there is something for you too in my talk. You'll not get bored. So why would we choose Kotlin? Well, first of all, Kotlin has a familiar syntax. It isn't some weird language that was born in academia. The syntax is familiar to any programmer that is coming from the object-oriented domain and can be more or less easy to understand from the beginning. The first thing we see when we come in contact with a new language is the hello world. And in Kotlin is just a 3-liner. I don't think anyone has any problem in understanding what it does. Kotlin has support for type inference. And Kotlin can infer your types whenever you feel that it might improve the readability. If we look at the code here, it compiles. And it compiles because the type is automatically inferred by the compiler. The compiler looks at this value, sees that it's a string, and it will automatically understand that the value is also a string. And the same thing happens with the age, where it's an int, 18 in this case. It's automatically inferred to the type int. Kotlin has support also for data classes. A data class is basically a POJO that comes with some methods already implemented, like toString equals hashcode copy. It looks like this. It just has the data modifier at the beginning of the class, and it automatically generates everything that you would normally need from a POJO. Kotlin was built with Java interoperability in mind, so it's 100% interoperable with Java. You can literally continue working on your old Java project using Kotlin. All of your favorite Java frameworks are available, and whatever framework you might use that is written in Kotlin, if it follows a series of simple rules, you can use it from Java as it was written in Java. So let's see if we call this from Java. It's just what we would expect. And we can also call it like this. Kotlin has support for null safety. If we think about Java, we call Java an almost statically typed language. In Java, a variable of type string is not guaranteed to refer to a string. It might refer to null. And Kotlin resolves this by distinguishing between nullable and non-nullable types. By default in Kotlin, everything is not null and can be made nullable by adding a question mark. If we look at this code, we get a compilation error, because if we look here at int, it's not a nullable type, and when we try to assign a null value, we get a compilation error. If we want to assign a null value, we just need to add a question mark after the type of the value. Kotlin also has support for extension functions. Since I think we all come from Java, I don't think that there is a program written in Java that doesn't have a utility class. And if it doesn't, it's probably just started. So in Kotlin, we can fix this by creating extension function. An extension function adds functionality to an existing class without changing the source code. So here, we are adding an is=to function to the string. And when we call it, it looks as if it was it belonged to the string class, even though it doesn't. It's code that we wrote. Kotlin has support for higher order functions. A higher order function is a function that takes as an argument another function or returns a function. In Kotlin, functions are treated as first-class citizens. You can assign variables to them. You can pass them to other functions as parameters. And this can be achieved with lambda expressions or function references. If the lambda expression has only one parameter, it will implicitly declared under the name it. So if we look here at the print, I hope everyone can see, at the print function, it says it plus 1. So it's actually the value here. OK, so let's do some code. What we're going to do today, we are going to migrate a Java application to Kotlin. It's not a very complicated application. It does some remote calls to 3 external systems, gets the user information by ID, then we go for that user ID and find the accounts for that user, and then for each account we go and get the transactions. So the response is a JSON that looks like this. And if we look at the code, we see that we have a model, which contains the Pojo classes. We have a remote, which is holding the clients, the REST clients that we use to get the information. We have a service that wires everything together, and a REST resource that will basically create an endpoint and expose it to the outside world. Okay. Let's start the app. Okay, let's see if it started correctly. Okay, so it works. So let's start with the user. The user here is a Pojo, is an immutable class that has an ID, first name, last name, email, country code, a list of accounts. It has an all arguments constructor. It has getters. It has equals. It has hash code. It has clone. It has a lot of code. When we migrate a Java application to Kotlin, IntelliJ has a very nice feature. If you go under code, it has convert Java file to Kotlin file. But if we look at this code, can everyone see it? So if we look at this code, we see that there is still a lot of noise. And basically, this class doesn't have any functionality. It's just a Pojo. So in Kotlin, we can remove all that. And just by adding the data keyword here, we transform it into a Pojo. Let's remove everything else that we don't need. Okay, we'll keep this one. So we changed everything. Now let's restart the application and see if it still works. Okay, so it still works. Now let's take some time to look at the code. The user Pojo is used in 2 places. It's used in the user client. Let's zoom it a little. but it's just returning a user. And it's used in another place, in the service. The service is the part where we wire everything together. And if you see, the user has get ID, get first name, get last name, get email, get country code. So from Java perspective, nothing changed, even though we migrated the user Pojo to Kotlin. From the Java perspective, nothing happened. So let's quickly change this as well. I'm going to use some IntelliJ Live templates so I don't have to rewrite everything. Convert, okay. And let's rerun it again and make sure that everything works. Okay, so everything still works. And if we look at the service we saw before, for example, here where we have an account, we see that we still get the getters that we would normally get if it was written in Java. So the model was pretty easy to migrate. We didn't have to do much, just add the data keyword and delete everything else. Now let's take a look at the user client. This is a Spring Boot application that uses a REST template, which is a bean defined here. Okay, so it uses this REST template. It does constructor injection, no auto-wired needed in Spring. To do constructor injection from version 4 something, I don't remember exactly. And we have a method that returns a user by its ID. And it's just calling exchange on some URL to get, and the response is a user class. But let's take a look at the getBody. GetBody comes from Spring Framework. It's based in the HTTP entity class. And we see something interesting here, nullable. So this means that the method definition is not correct because it will return either a user or null. This is called partial functions. Well, a function is called partial when only for a given subset of x, from x to y, it will return the y. So this is the case here. If we call getUser by ID 1 to 3, it will return a user. If we call it by 3 to 1, it will return null. But the function definition says that it will return a user, which is not correct. So let's try to fix it. First of all, let's convert it to Kotlin. And if you see here, it added automatically the question mark. So this means that it is a nullable type. And if we go to the service, the ID gives me a warning. It says that the method infogation getID may produce a null pointer exception. It didn't do that before when the client was in Java, but now the IDE knows that I specifically told it in the signature that this is a nullable type. So how do we fix this? Well, usually the first thing that comes to mind is to create a simple response with a generic type and an error. We'll see in a moment how are we going to use this. But first, let's fix something here. In order for the Spring value annotation to work, this is one of the ways you can fix it, you need to add the late init var. What the late init does, it tells the compiler, okay, don't worry that this is not initialized right now, because if we delete it, we get a warning, an error actually, that the property must be initialized or it must be abstract. So we're telling the compiler, don't worry that I didn't initialize this. It will be initialized later after the Spring has created its context and the beans are injected and it's looking at the properties and puts the properties together and so on. So just by adding the late init keyword, I am able to run the code. But there's another thing I don't like here. For example, I don't want to do this. So let's delete it. But now I get a compilation error, obviously. But the guys at Pivotal from Spring 5 and Spring Boot 2, they added support for Kotlin as a first-class language in the framework. So what they did, they created some extension functions over their existing APIs that are able to leverage the power of Kotlin. So if we look at this extension function, we see that it is inlined and reified. And let's see what it says. It's leveraging the Kotlin reified type parameters. This extension is not subject to type erasure and retain actual generic type arguments. Why does this happen? Well, first of all, we're using reified generics. We're saying that the T is a reified type, and you can only add reified in inline functions. So inline is just a fancy name. Hadi says that, and I like it very much. Inline is just a fancy name for copy-paste. What the compiler will do, will copy the body of the method wherever it is used. And by doing this, we are able to keep the type at runtime. Okay. Another thing we don't like here is that we have a string format, blah, 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 blah. I don't want this. I don't like it. And apparently in Kotlin, we have something called string templates. Problem fixed. Let's do this a one-liner. Let's rerun it and see if it works. Okay, so I changed the client and the code still works. Okay, I said earlier that this function is a partial function. And instead of returning a user, let's return a response of user. And here we can say try and catch exception. And here we return return response where the error is true. And let's copy this. And here we are returning a response where the data is the user. If you look at the IDE, it's already telling me, it's giving me a hint that the return should be lifted out of try. Okay, let's see what this means. In Kotlin, statements like try, if, and others are also expressions, and you can return from them. So here, instead of returning on the try and returning on the catch, we're returning an upper level where we declare the try. Okay, this looks nice, but how will it look for a client? Let's create here some demo client that will use the user client. Here we say the response is equal to user client get by ID 1, 2, 3. Okay, so I have the response, but what do I do with it? I know that the response could have something inside it or could have an error. So I would have to say if the response is an error, I don't know, print line error, else print line, let's say response.data. So if we look at this code, it's not very nice. Think about it. when we have multiple clients that we have to call. Let's refactor this, the other clients like this, and try to chain them. And we'll see that for every else, we'll have to do an if for the other response, and then we have to do another if, and the code becomes very difficult to read, and it's quite ugly. So this is not a solution, but how could we fix this? Well, apparently, we have a solution. It's called algebraic data types. So in computer programming, especially in functional programming and type theory, an algebraic data type is a type that is a composite type that is made of other types. In Kotlin, we can achieve this with sealed classes, which are used exactly for this purpose, to represent class hierarchies that are limited. So when a value can have only one of the types that are limited. And we're going to see immediately what that means. If we go back to the code, let's delete this, delete everything. And the sealed class looks like this. It has the sealed modifier at the beginning. And then we have two classes, one success and one failure. And inside the success, we have a generic type. And inside the failure, we have some string. It doesn't really matter. We can create sealed classes like this, or we can put everything inside the class. The difference is, if we put them inside, when we call them, we have to say response.success and response.failure. And it looks better, I think, in code like this, if we keep it like this. Another interesting thing about sealed classes, if we go to another Kotlin file, let's say that we have a class called something, and this, we want this class to be a response as well. It turns out that we cannot. Why? Because the subtypes of a sealed class can only be put in the same file. And this is a design choice that they made, and I think it's a very good one, because it limits the possibility of errors. So we are in the class where the subtypes are. So let's try to change this. Instead of returning a response of users, we're going to return a response. And here we are going to say success. And here we are going to say failure. Well, the cause is... If you look at this, we see that we get a compilation error again, because it requires a string and not a string that can be null. So apparently, if we look at the message returns a nullable string. How can we fix this? Well, it's quite easy. If the message is null, the compiler will put some error code inside the failure. So we fixed this issue. Now, how does this look from a client? Let's do the same thing we did earlier. And here we put the user client. And we have a response. We could do the same thing, if, else, but there's a better way. We can use when. When is just like switch in Java, but it's a lot more powerful. It's not as powerful as the pattern matching in Scala, but it's anyway a pretty powerful construct, language construct. So when response, and let's say is success something is failure. I don't know. Usually, even in Java switch statements, we should say the default if none of the above values are present. But in this case, the compiler already knows that the else is redundant here. Why is that? Because the response can only be of type success or failure. And we fix the issue. So we could delete it. So this looks nice, or it looks nicer than it was before. But we still have some problems here. The problem I told you earlier. When we want to chain these, when we want to chain calls, or when we want to chain functions. And it's going to be difficult because we can do the same thing here. If it's a success, I go to the account client. And here I have another when. And if that returns a success, I do another when that goes to another service. And this is not good. It's not very maintainable code. It's quite hard to read. And there must be a better solution for this. And it turns out that there is a solution. Let's go back to the presentation. And that solution is Monads. Monads come also from functional programming. And the monad is a design pattern that allows you to structure computation in a way that it's both generic and declarative. Yeah, this is the reaction I had when I read this the first time. Really? Monads? What is that? It turns out that it's not something that complicated. Of course, in order to be a monad, it has to respect some monad laws and so on. But the very basic definition you can give to a monad is this. So we have a monad over some generic type that has only two functions, just and flatmap. Just is only used to put something, an object, inside a container, where f is the container. And flatmap is used to replace one contained object with another contained object. Why is this important? Because flatmaps allows us to do composition and function composition. In Kotlin, it's not possible right now to have something like f of a. So we cannot have a generic type and inside it something else generic. But there is a keep opened, keep our language features, to bring support for type classes in Kotlin. But what we can do right now, we can use Arrow. Arrow is a library for typed functional programming in Kotlin. And what they want to provide is a common language of interfaces and abstractions to Kotlin libraries. So how do they look? How does this look inside the code? We are going to touch only some basic functional data types right now, like option, try, and either. And we're going to see how we can use them to get our code better. So here, instead of returning a response, let's return an option of user. But this is no longer going to work. And we have a user, and we'll return an option from nullable of user. So this looks nice because we get flatmap and we get composition, but we lost something that we had before, error handling. And in any production application, you always handle errors. You cannot forget about runtime's error when you go to production. It's very important. So option for this case is not a good match. But there's something else called try. Try does exactly what you might expect, wraps the call inside the try, and on the catch, it will return the error. And here, instead of returning an option from nullable, we'll return a try of user. Okay, so this is nice, but we have another problem. Try here doesn't return a user. Try here returns a nullable user, and we wanted to fix that problem. And apparently option doesn't work, try doesn't work, but we have another functional data type that is called either. Either is basically like a pair. It has a left side and a right side. Typically on the left side you keep the error, and on the right side you keep the success. But in order to model that, and in order to have also the business exception handling that we need, we'll have to create another sealed class called failure. And this contains a status and a message. And inside it, we define all the possible business errors that might come. So we have a user not found if we're not finding the user. We have accounts not found if we don't get any accounts for that user. We have transactions not found and some unknown error. And how do we do this? Well, we could do it like this. We could still keep the try. And since try returns a value in Kotlin, we can just say equals try. We drop this. And now we have what we had before. If you see here, the IDE is telling me the return type, which is a try of a nullable user. There's another handy method on option, on try, on either, and it's called fold. When we fold the response, it has two sides. The error side, which is here, and here we have a throwable. And we have the user, which is a nullable user here. And on the fold, we could say, we could use if or when or whatever, and say when user null, return user not found, else return the user. We could do it like this, or we could do it by using what the language offers us. So let's try to replace this with a try. Instead of fold, let's do a catch. Here we have the user. And we said that we want to return an either. To return an either, we can do something like this. User.write. But it's not enough. What if the user is not present? This will return to me an either of something and a nullable user. But by adding the question mark here, I fix the problem. And if the user is null, I can return user not found error and put it on the left side. And if we get an exception, we return an unknown error and we put it on the left. And right now the signature changed. It changed from any, which any is like object in Java, is the top type. We change it to an either, that it is either a failure or a user. This failure could be user not found if the user is null, or it could be unknown error if we don't know what happened. So yeah, this looks nice, but if we go here to the service, it's not working anymore. So the moment we introduced those functional data types, the code no longer compiles in Java, because here is not waiting for a user. So we were expecting a user, but we're not getting a user anymore. We're getting an either. But before we fix this, let's go to the clients, the other clients, and fix them as well. We're doing the same thing, converting. And here I'm going to use oh no. So we're doing basically the same thing. We're returning either a failure or list of accounts. And if we go to the transaction and do the same thing, okay, so now all of our clients return an either. But the service doesn't compile anymore. The reason we went on this road is to handle the exceptions for the business and to have function composition. We did that, but you might think, okay, you're using a Spring Boot application. Why aren't you using, for example, a controller advice to handle the exceptions? Well, we could do that, but if we want to migrate the code from Spring Web MVC to Spring Webflux, that will not work anymore. But by doing it like this, it will work with Web MVC and with Webflux as well. And we have to convert this code to Kotlin. Okay. Let's zoom in a little and take a look at it. So, okay, we have function composition. Because of the flat map, we get the user client. Then for the user, we go to the account client and get the accounts for that user. And then for each account, we go to the transaction client and get the transactions for each account. This is not very readable and not very maintainable. Think about it. If we had not 3 clients, but 6 clients or 10 clients, we will get the callback hell that we used to have in JavaScript before promises and stuff like that. So how could we fix that? Well, there is a solution for this. It comes from functional programming as well. That is called monad comprehension or for comprehension. And it looks like this. Let's do the imports. Yeah. It's easier to import this before. So let's look at the code now. We have the user, which we get it from the user client. And remember, it returned an either. It didn't return a user. But we have the method bind. So this bind, what it actually does, it's delegating to the, it's actually a suspension function in the Kotlin coroutine context that delegates the execution to flat map. When the flat map has finished its execution, it gives us the value, and we get it here. And we have the user, we have the accounts, and then for each account, we go to the transaction client and get the accounts by the ID. So this looks a lot more familiar. It looks like imperative code, but it's actually not imperative code. And this is similar, as I said, to the for comprehensions we have in Scala with for and yield. Now, let's take a look at the resource. Because this doesn't compile anymore, obviously, because it expected the user and is not a user anymore. We have an either. So let's fix this. I can do this without migration the code, without code migration to Kotlin. I can do something like this. Fold, remember fold? On option, on try, on either. Actually, I can call it from Java as well. If it's a failure, we return a response entity that has the failure, and the failure gets status. And if it's a success, a user in this case, we return a response entity of user. Okay. And let's return from here. Let's see if it compiles. Yes, this got here when I was showing you the sealed classes. And it works. And if we try to get a user that doesn't exist, we get this, status not found, user not found. How do you think this happens? This happens here as well. In the user service where we have this monad comprehension, what happens is that if an error occurs and we get an either of left, the execution is short-circuited and it comes out with the left value. So here, if we don't find the user, what we will actually return is failure of user not found. If we go back to the code, to the account client, get user by ID, the same story. We get the accounts not found, and so on. If an unknown error happens, we get the unknown error when it happens. So this way, we treated the errors without writing basically any code, and just by using what monad comprehension and functional programming has to offer to us. Okay. Let's go back to the presentation. Okay, so takeaways. What I want you to understand is that Kotlin is not a silver bullet. It's not going to magically solve all of your problems if you adopt Kotlin. But if you choose to adopt Kotlin, there are some things that you should be aware of. You should always start with the data class and the unit tests, especially with the unit tests, because if you start with unit tests, the whole team will get to know the language without breaking any production code. So you keep your production code in Java, and you write your tests in Kotlin, and this way you learn the language, you learn its features, but you don't break any production code. When you get comfortable enough with the language, you can move to the production code, and my advice is always to start with the data classes. Only change the POJOs. Use expressions as much as possible. Try to use top-level or extension functions for utility functions. Avoid if null. Try to prefer the question mark. And a good practice is to use sealed classes for closed type hierarchies. We saw that before. When we have a when expression, we don't have to use the else. We know exactly that if the response was a success and a failure, we basically know that it cannot be anything else. So try to use that as much as possible. As I said in the beginning, I'm the organizer of Kotlin user group, Bucharest. This was started in early 2017. So we're trying to grow the community and grow the interest into the Kotlin programming language. So if you are interested, please join. If you want to talk about Kotlin or you have something interesting to say about Kotlin, we're more than happy to welcome new speakers. And okay, that's about it. I finished earlier than I thought. So if you have any question, now is the time to answer. If I cannot have an answer, Venkat will surely know the answer. So, any questions?
Can you show this home file? I suppose there's some settings.
Yes, yes, of course. I can do that. So this is, oh, sorry. So this is a Spring Boot app, but in order to have Kotlin, you need these two dependencies, and it's not enough. You also need a compiler plugin, which is this one, Kotlin Maven plugin. It has a lot of stuff in it that you can, I don't know, for example, the Spring plugin. In Kotlin, by default, all the classes are closed. So it's not like in Java where we have everything public, everything is closed. So in order to use the Spring framework, we either use open everywhere, or we can use the Kotlin Maven all open plugin. At compile time, it will look for the classes that are annotated with Spring annotations and open them automatically. So what you need is these two dependencies, the plugin, and if you want to use Arrow, you can start with the Arrow core. They actually released version 0.90 a few days ago, and they restructured a little bit the packaging. But either try option or in the Arrow core module. So you can start with that. Okay?
And another question, is there any way to see the Java class from...
Yes, yes, of course. So let's look at the user. In IntelliJ, under Tools, Kotlin, you have Show Kotlin bytecode. And it's going to show us the bytecode, but of course we're not interested in bytecode. If we decompile, we get some metadata that the compiler uses, and we see that we have private final string ID, private final string first name, and so on. Then we have the getters that we had in our Java class at the beginning. Then we have the constructor. Then we have component 1, 2, 3, 4. I don't go into detail right now. This is useful for tuples, for example. We have the copy. If we look at the service here, we're not returning the user. So when we get the user here, we don't have the accounts. But we don't go at the end and say user.accounts equals something, because we cannot do that. It's an immutable object. But what we can do, we can use the copy function, and inside the copy function, we can change only what we want. So for example, here, I can change the ID if I want, and say ID equals 1, 2, 3, equals, sorry, 1, 2, 3. But I'm not actually modifying this. I'm returning a copy of it that has only the fields that I want, the properties that I want modified.
So you actually decompile the class file?
Yes.
Any words about the licensing?
What do you mean by the licensing?
Is it free to use in production?
Yes. Yes, of course. It's open source. You can use it in production. You can use it with OpenJDK. If you go for JDK 11, you can use it with OpenJDK, and it works just fine. So, if you don't have any more questions, thank you. That was it. I hope it was useful for you. And thank you for coming again.